Hello and welcome everyone. In this chapter we will discuss about administrative distance and matrix. So the concept of administrative distance and matrix is very important to understand in terms of routing and the routing protocols. So just to take an example here, consider we have the multiple routers. Let's say this is one router and another router and some more routers are here. Let's say here, here and here, and connectivity between the routers also is defined like this. See, this is basically the symbolic representation of serial cable. Symbolic representation of serial cable. Let's say this is the connectivity, and consider one of the PC which is here. Consider another PC here. Fine. And this is, let's say, router 1, router 2, 3, 4, 5. Now say for example we have this as source and this I am considering as destination routers. Now from this router 1 to reach this particular router 5 we have two different paths. Let me give you little more additional information in this. Let's say this is 10.0.0.0 network and this is 11.0.0.0 network. Fine. So from this router 1 to reach 11.0.0.0 you have two paths. One path is via router 2, another path is via router 3. Now which will be the best path in this to reach the particular routing, a particular 11.0.0.1? This will be defined by using matrix. Always remember, whenever we have more than one path to reach the same destination network, in that case we are going to use the matrix to define which is the best path for us. For example, let's say some matrix value here. I am just keeping a random number. Let's say matrix value is 100, matrix value is 100, matrix value is 10. Here 100, here 100, 100. So always remember, matrix is some kind of number, 1 2 3 4 5 6, something, some number which is used to define the best path in available path, and always the least matrix will be the best path. So say for example the matrix via router 2 to reach this particular 11.0.0.2, just count 10 plus 100 plus 100, 210 is the matrix. Via this 100, 110, 210, 310, 310, correct? Now see, via router 2 and via router 3 you can reach, but the best path will be the least matrix only. So which is the least matrix in this? As 210 is the less than 310, so this is going to be your best path to reach the destination. It's all about, from this you can forward your data, your routers will forward the informations via this, and your communications will take place. So by this I believe it should be clear to you when we will be using the matrix. It's all about, matrix is the number, something like 1 2 3 4, some number which is used to define the best path if you have the multiple paths available to reach some destinations, and always the least matrix will be considered as the best matrix. This is the very first concept. Now let's take one more scenario to understand the administrative distance. Say this. Say for example, I'll take the same scenario again. Let's say some router and another router is here, and the connectivity between the router is again via serial, and you have some LAN segment here and you have some LAN segment here as well. Let's say this is your LAN segment. Consider this is your PC A, your PC B, router 1 and router 2. This is, let's say, your 10.0.0. network. This is 11.0.0 network. Fine. I will consider this as my source and I will consider this as my destination. So for this particular router 1, it has to reach the destination, and the destination is 11.0.0.0. Fine. Now for router 1, 11.0.0.0 is the indirectly connected network, and to reach this particular network we can go ahead and configure the routing itself. That could be static routing or maybe dynamic routing protocol. Say for example, I am going to configure the RIP. I am configuring RIP. Definitely by using this RIP, routing information protocol itself, you will be able to communicate. Let's say in the same routers I am going to configure EIGRP as well. I am going to configure the OSPF also. So now tell me which one will be the best routing protocols to reach this particular 11.0.0.0. I mean, you can configure the multiple routing protocols to reach the same destination, but the routers will get confused whether which one should I use to go for this. So that's where your administrative distance comes into the picture. Administrative distance will be into the picture now. So again, administrative distance is also some number which is given by the developers, and this number is basically used to categorize your routing information. Also you can say the reliability of routing informations can be trusted by using administrative distance. For example, they have given the number for this as 120, for this they have given as 90, for this they have given 110. Always remember, administrative distance is equal to trustworthiness of the routing information or the reliability of your routing informations. How much reliable is. So in this, if you see, the reliability will be defined based on least privilege principle. It's like least value will be the best protocol. So in this, what is the lesser number? 90 means 90. This one will be used to forward your information from here to here. EIGRP will be used. Say for example, if I am going to remove the EIGRP from this list itself. Let's say I have removed the EIGRP from here. If you remove the lesser number, again lesser number is going to be your 110. The communications will be possible by using OSPF. Let's say, what if I go ahead and configure a routing like a static routing. For a static, the value is 1, means it is going to trust on your this one. So the administrative distance is all about trustworthiness of your routing information, and lesser the administrative distance, higher the priority will be treated. This is the scenario to understand your administrative distance. Again, you might be confused, what is this number 120, 90, 1 and all. Don't worry, I will give you the list of it so that you can understand better. So let's get back to our slide and see that in complete details again. But remember, this scenario is very important. See this. So administrative distance, this is a feature that a router used to have the order to select the best path, or this is the features by using this routers will define the order of your routing protocols, which is the best one. Make sure, this is the scenario, when there are two or more different routers to reach the same destination from two different routing protocols. In that case also, your administrative distance is going to help. See, read this. Administrative distance defines the reliability of your routing information or trustworthiness of your routing information. So for connected network, administrative distance will be 0. For a static route, administrative distance will be 1. For EIGRP, always remember, for EIGRP you have 90. What is this external EIGRP? Again, this is external, we are 170. OSPF 110, RIP 120. So at least this table you need to remember. Now, metric, as we discussed already, read this. It is a criteria to choose the best path, and read the example. If router is aware of two paths to reach the destination with the same administrative distance, then routers will look for the metric value to choose the best path. Now, that's it for this lecture. We will see you in the next lecture. Thank you.